Assalamualaikum doctor. We are from group 2 and my name is Md.Sadman Sakib and my metric number is 20037. Now I'm going to give introduction on trust system. Trust. Trust is a rigid construction that consists of a collection of discrete members. There are two assumptions that need to be made before considering that a structure is a trust. First, we need to conclude that the joints with a attachment are linked to the members of a trust and that the members are free to rotate at the joint. Although all the members are bound by a gusset plate, it is fair to conclude that the joint conducts as a plane link if the centered lines of all the members at a joint converge at the same point. Secondly, we have to assume that all the loads are applied only to truss joints, which ensures that there will be no force acting on the center of a member. In addition, each member must be in balance of forces and the strength must be equal and opposite, rendering a member either in compression or in stress. Trusses, hang racks, cranes, bridges, or even antenna towers are everywhere in our everyday life. By using materials in a very powerful and cost-effective way, they are used to build structures of incredible strength. Now Farhan will explain the truss system.
Hello, my name is Farhan and my matrix number is 204801, and today I'll be doing the presentation for statics uh, for assignment 1, which is trusses. So in my assignment I've used the Atkinson truss bridge. This bridge is located in uh, United States, and it has a span of 56 meters. So there are some assumptions that we need to use to find out the forces of the joints and the whole bridge. So the first assumption is all the members are connected only at the ends by frictionless hinges in the plane trusses and by frictionless bell and socket joint in the space trusses. All loads and supports reactions are applied only at the joints. The centroidal axis of each member coincides with the line connecting the centers of the adjacent joints. So over here we can see the length of the Atkinson of one side of the Atkinson bridge, and the like we have assumed that there is a truck in the middle of the bridge which weighs about 16,500 kilograms and is evenly distributed between the front and rear axles, and the axles are 6.4 meters apart. And the forces in over here are found out by dividing the wheels into four parts. So now what we have to do is separate the joints to find out each forces. So over here we have to use the equations of motions, and as it is statics, the summation of the forces and the summation of the momentums are zero. So over here we have separated joint A, then joint N, then joint B and joint M, and then joint C, and lastly we have cut a substructure to find the internal forces. And then at the end we have found out each force in the whole structure. We can notice in these circles that there are no forces over here. The forces is zero, and we only have got the half of the cross bridge. As the other half is a symmetry, we can assume that the forces in one half is equal to the forces in the other half. And over here we can see each section over here has forces. And as I mentioned, the circles are like there are no forces over there. So this is my presentation, and thank you very much, and I hope you liked it.
Okay, now let's move to the conclusion part of trust system. The basic shape of the triangle of the arrangement of the linear rod in the balance of a tensile compressive forces forming the truss frame structure its system is the basis for the creation of a truss structure system, especially joints or flexible joints in the truss. In following the shape of the bridge, the truss structure system is very flexible so that its use is very broad and varied both in terms of structure, dimensions, and profiles of the truss and construction structured materials, so that the truss structure plays an important role in realizing the design forms of architects, especially roof construction, in order to reach a stable level of and also strength of the objects or buildings or bridges. Okay, now let's move to the introduction part of frame system. Frames are built-up structural and mechanical systems consisting of multiple parts and assembled in several possible ways. For example, the parts could be being connected or welded together. Frames is a structure in which at least one member is multi-force member. The primary difference between frames and machines is that there are moving parts in machines and not in frames. The method of analysis is the same. The solution to this system usually requires drawing of the free body diagrams of individual parts and the application of the equilibrium equations. Therefore, one must be careful in recognizing the existence of two force members that could identify the direction of the unknown force. Now, Azril will explain the now Azril will explain frame system.
My name is Muhammad Azril bin Muhammad Rizalman. My message number is 201030. Okay, today I will explain about frames. The location of structure is at Slim River, Perak, which is near my house. Okay, next, assumption that our group made. The most important element in the solution process is to set up a free body diagram for a rigid body equilibrium problem. We would not be able to write down the correct condition of equilibrium without right setup of the diagram. This shown that free body diagram is very important to calculate the calculation. Okay. Okay. Next, the picture of structure. Okay. Here is the stair that I took. Okay. It has a frame in it. Okay. Okay. Next, free body diagram structure. Okay. Here is the free body diagram structure, and I label it as A, B, C, D, and E. Okay. Okay. Here, direction and external load on structure. Okay. Here I do some the calculation about how to find the member ABC, member BD, and member CDE. Okay. First, for member ABC, we calculate the totals of fx and then total of fy and use the total of moment at C. Okay, member BD we only need to calculate the total of sum fx because it only have one force, uh, one direction. Okay, next for member CDE, uh, the total of sum fx and total of sum fy and total of moment at C. Okay, that's all for me.
Okay, now let's move to the conclusion part of frame system. Frame structures are more complex than beams because they do not necessarily all lie along a straight line as beams do. In frames, there can be both vertical members and members that are inclined on an angle. Frames also have added complexity of potentially inclined members as well as the inclusion of axial forces in the analysis. Now I'm going to give introduction on machine system. Frames and machines are structures similar to trusses except that they have at least one member that is multi-force member, and a multi-force member is an independent piece of the system that has three or more forces acting on it. Frames are designed to support loads and are generally stationary. Machines contain moving parts that transmit or alter applied forces. Now Said will explain the machine system.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Said Hafidh Said, matric number 204716, and I'm going to continue with the location of machine. The picture of this machine was taken at home, but it can be found in construction site. It is used as lever either to force apart two objects or to remove nails. Crowbars are commonly used to open nailed wooden crates. Common uses for larger crowbars are removing nails, prying apart boards, and generally breaking things. But also, crowbars can be used in gardening. Assumption made in this machine. The first assumption is the crowbar does not bend. This means that when you use the crowbar, it remains with the same length and it does not bend, that is, it remains straight. Also, the length of the crowbar is constant, that is, it does not have elastic property. The momentum of the crowbar remains constant and the length does not change either by reducing or increasing. Also, the crowbar can withstand load without breaking. That is, when we use to remove nails or we remove to break things apart, the crowbar does not break and it can stand any amount of load. And lastly, the machine or crowbar supporting surface is strong to withstand forces and can provide a reaction force on the crowbar. If you use crowbar at a sand, it cannot break apart things because the sand surface does not produce the needed reaction force on the load. As we can see, this is the picture of the crowbar. This is the full picture of the crowbar. And this is the top part, and this is the lower bottom of the crowbar. The free body diagram of the structure. The force that the crowbar applies to the nail, that is F0, is not a force on the crowbar. The reaction force the nail exerts back on the crowbar, that is Fn, is an external force and is equal and opposite to F0. The perpendicular lever arm of the input and the output forces are Li and L0. Here you can see L0. The reaction and the external load on the structure. By using the equilibrium equation, summation of horizontal force, that is Fx, is equal to 0. And since there's no force along the x-axis, hence Fx is equal to 0. But the summation of vertical forces also is equal to 0. And there are three vertical forces, as we can see from the free body diagram, that is Fn, N, and Fi. So Fi minus N plus Fn is equal to 0, hence force input is equal to the normal force minus the Fn. Also, summation of moment of the system is equal to 0. Hence, the force input times its moment arm times the force Fn times the length N, which is equal to length naught. Hence, a force input times length of input is equal to force normal times length of normal. The mechanical advantage of the crowbar can be written as Fn minus Fi. That is the normal force, which is equal to the force output divided by the force input. And rearranging this from the third equation, we can get that length of input divided by the length of normal, that is length of the output, is equal to the mechanical advantage. Thank you.
Now let's move to the conclusion part of machine system. We have used crowbar in this assignment. Crowbar is widely used in many applications. It's single metal bar with a single curved end and flattened points, often with a small fissure on one or both ends for removing nails or to force apart two objects. The iron lever is used to open nailed wooden plates, pry apart boards. They're made up of iron or carbon steel, but nowadays they are also made up of stainless steel or titanium. A frame is a rigid structure while a machine is not rigid. This means that no part can move relative to the other parts in frame, while parts can move relative to one another in a machine. That's all from our group, Doctor. Thank you, Doctor.